Alright, hello everyone. This is Engineer Ruiz and we are here for the DC analysis of BJT circuits. Okay, so dito sa DC analysis, okay, isa-solve natin yung parameters ng BJT circuit, okay, na DC pa lang ang source. Ibig sabihin, wala pa tayong AC source na ina-apply dito sa circuit. Okay, so BJT circuits, meron siyang tatlong fundamental configurations, no? Andito yung common emitter, common base, and common collector. Now, under common emitter, marami pang configurations na nakapaloob dyan. Okay, so umpisa natin sa common emitter. Common emitter or abbreviated as CE. Okay, ganito ang structure niya. Meron tayong BJT. Okay. The emitter is connected to the ground. The collector, siya yung connected to the output. And the input dito sa common emitter is connected sa base. Okay, take note. No. Yung isang pin ng input is nakakonect sa ground din. While ganun din sa output, yung isang pin ng output is connected din sa ground. Okay. Now, both yung isang pin ng input at isang pin ng output is connected to the emitter. And that is the reason why it is called the common emitter. Okay, tanda mabuti, ang input sa common emitter ay nasa base, ang output ay nasa collector, and yung common nilang dalawa ng input at output is nasa emitter. Now, under ng common emitter configuration, okay, andito yung una, the fixed bias configuration. Dito sa fixed bias configuration, siya yung pinakasimpleng configuration ng transistor. Okay? Meron lang siyang base resistor and collector resistor. Meron tayong positive VCC, okay? Itong positive VCC, una, ginagamit yan para i-turn on yung diode or yung PN junction ng base to emitter para maging, okay, para magkaroon ng operation or para maging active yung BJT at makapag-operate siya either as a switch or an amplifier. Okay, so yun yung purpose ng base resistance na dinagdag dito sa BJT. And also, itong BCC connected to the collector, okay, siya yung magiging source or sa kanya manggagaling yung power, okay, para magkaroon ng collector current or para ma-drive yung output nitong BJT. Dito naman sa emitter stabilized bias, okay, meron pa rin siyang base resistor and meron siyang collector resistor, but this time may dinagdag tayong emitter resistance or the emitter resistor. Okay, may purpose yan. Dinagdag yung emitter resistor or yung emitter resistance na yan for stability. And later, pag nandun na tayo sa amplifiers, I'll explain kung paano siya nagiging mas stable gamit itong emitter resistance na to. And bakit ba kailangan maging stable? And also, meron din tayong tinatawag na voltage divider bias and the collector feedback. Okay, so bawat resistor na dinadagdag dyan, may purpose yan. Okay, ang main purpose nitong mga resistor na to na dinagdag natin is number one, for stability. Kasi nga, si BJT, okay, gaya na napag-usapan natin, si BJT is a semiconductor device. And semiconductor device, okay, yung mga devices natin are highly dependent sa temperature. Okay, or sa environment na kung saan siya nag-ooperate. So, yung beta, nagva-vary yun. Yung BVE, nagva-vary din yun. Okay, thus making the device unstable. Okay, and for better stability, okay, dinadagdag itong mga feedback resistance, dinagdagan ng R1, R2, and dinagdagan ng emitter resistance. And si voltage divider bias, okay, siya nga yung pinakamaraming resistor sa circuit niya, and ang advantage naman nito, siya yung pinaka-stable. Okay? And take note also, gaya ng sabi ko kanina na sa common emitter, okay, ang input is nasa base. Okay, so Kapag gagamitin natin siya as amplifier, okay, andito ang input, and nandito ang output. Okay, ganun din dito. Ang input is nasa base, at ang output ay nasa collector. Okay, ganun din dito sa fixed bias and si emitter stabilized bias, okay? Ang input is nasa base, while ang output ay nasa collector. At ang common nila ay ang emitter. Okay, and dito sa BJT, meron tayong tinatawag na primary constants. Okay, ano ba itong primary constants na to? Okay, ang primary constants, okay, sila yung constants na kahit hindi given sa circuit, okay, kahit hindi siya sinabi sa problem, alam natin or meron tayong default values na ginagamit. For example, ang value ng base to emitter voltage kapag naka-on ang transistor, automatic, kahit hindi siya given, meron tayong default value na 0.7 volts. Okay, isa pa. Ang VCE, when saturated, or VCE sat, ang value ng VCE kapag nasa saturation mode ang transistor is by default equal to 0 volts. Okay. The collector current or to emitter current during cut-off. Okay, since cut-off ito, naka-off yung transistor, kahit hindi siya given, okay, by default, alam natin na 0 ampere yan. And also, meron ding transfer constant. Okay, dito sa BJT, okay, di ba? Napag-usapan natin na ang transfer function ng BJT at active mode is IC equals beta IB, no? Okay, this is the transfer function. Transfer function. Okay, ang transfer constant dito sa BJT is itong beta. Okay? So, ang transfer constants dito sa BJT is beta. Okay? And yung beta na yan, nakadepende sa karakteristik ng transistor. Depende sa transistor na ginamit. Okay, depende sa transistor na ginagamit natin. Okay. Minsan, hindi beta ang given, pwede rin alpha. Or minsan, pwede rin yung gamma. Depende sa given. But most likely, okay, mas madalas ang ginigiven dito is yung beta. Okay, tanda mabuti. Para makapag-solve tayo ng circuit, meron tayong tinatawag na primary constants, VBE, VCE at ICEO. Okay, sa BJT. And ang transfer constant sa BJT, primarily ang ginagamit is yung beta, which is nakadepende sa transistor na ginagamit natin. And for our problem number 1, okay, so focus muna tayo sa common emitter. Soon ko na i-explain sa inyo kung ano yung common base and yung common collector. But for now, magsosolve muna tayo ng problem sa common emitter. Okay, meron tayong fixed bias, okay, na ang base resistor natin, ang resistance niya ay 470 kilo ohms. May VCC tayo na positive 12 volts. And the collector resistance is 2.2 kilo ohms. Okay, sorry, kulang yung given. Okay, meron tayong beta, kunwari is 100. Now, before anything else, kapag magsosolve tayo ng transistor circuits, okay, before we start anything na kailangan nating hanapin, which in this case, di ko rin naisulat. Okay, so hanapin ang IB, IC, IE, and BCE. Okay. Now, again, before anything else, lalo na kapag magsosolve tayo ng IC at IE, para safe tayo, let's solve first for the IC SAT or the IC saturation current. Okay, para malaman natin kung ano ba yung maximum na value ng collector current para hindi tayo magkamali. Okay, now to solve for the IC SAT, okay, magliloop na tayo agad dito sa output side or dito sa collector side. Okay, para madaanan yung VCE. Okay, mag-loop tayo, okay? Tatawagin natin siyang loop number 1. Okay, by KVL, loop number 1, sum of voltages will be equal to 0. Makukuha natin na VCC minus ICRC minus VCE, that is equal to 0. Okay, para makuha natin yung IC sat, VCE, okay, VCE will be equal to the VCE when saturated, or the VCE sat. Okay, ang value ni VCE sat, since primary constant siya, okay, and hindi naman siya given, so gagamitin natin yung default value niya, which is 0 volts. Okay, so meron tayong VCE, meron tayong VCC, meron tayong RC. Now we can solve for the IC, or the collector current. Okay, i-manipulate lang natin tong equation number 1, okay? Ita-transpose natin tong IC times RC sa kabila para maging positive, and i-divide natin both sides of the equation by the collector resistance para maiwan yung IC sa isang side. So IC, after manipulating this equation, so IC is equal to VCC minus VCE, okay, VCE sat na, and si IC is IC sat, okay, divided by RC. So by substituting the values, we now have 12 volts minus 0 divided by RC, which is 2.2 kilo ohms. So makukuha natin ang IC saturation current is equal to 5.45 milliamperes. Okay, so nakuha natin yung IC saturation current. Now later, kapag nag-solve tayo ng IC or the collector current or the IE, dapat hindi siya, okay, hindi siya dapat lalagpas dito sa collector current. Okay, or sa IC saturation current. Okay, so now we will now solve for IB. Okay, and take note also, kapag analysis ng circuit, lagi tayo mag-uumpisa sa input and papunta tayo sa output. Okay, so umpisahan natin sa input. Since meron tayong loop number 1, so loop number 2 na ang tawag dito. At sa loop number 2, okay, by KVL again, meron tayong equation na VCC minus IBRB minus VBE, that is equal to 0. Now, VBE, okay, VBE will be equal to the VBE kapag naka-on yung transistor, and again, it is a primary constant, which is kahit hindi siya given, alam natin na may default value yan na 0.7 volts. Okay, and by manipulating this equation, okay, ito-transpose ulit natin itong IBRB sa kabila, and di-divide natin both sides of the equation by RB. Makukuha natin IB is equal to VCC minus VBE, okay, on, divided by RB, or the base resistance, and that is equal to 12 volts minus 0.7 divided by RB, which is 470 kilo ohms. At ang makukuha natin sa IB ay 24.04 microamperes. Okay, meron na tayong input parameter, which is the base current. Okay, by the way, ang input parameter ng BJT is the base current, kasi nga ang BJT ay current controlled current source. Now, since current source siya, ang output parameter is the collector current. And para makuha natin itong collector current, gagamitin natin yung transfer function, which is IC is equal to beta times IB. Okay, si beta, transfer constant siya, which is given 100 ang value. So, makukuha natin IC is equal to 100 multiplied by IB, which is 24.04 microamperes. Now, makukuha natin ang IC is 2.404 milliamperes. Okay, so ayan, kita natin na ang IC o yung IC na nasolve natin by KVL is less than the IC saturation current. So therefore, 2.404 milliamperes will be the final answer. Okay, so hindi siya sumobra sa 5.45 milliamperes. Tama ang sagot na to. Now, to solve for IE, or the emitter current, IE by KCL. Okay, by the way, yung base current is papasok dito sa transistor. Ganon din ang collector current. And ang palabas na current is the emitter current. Okay, so by KCL, current entering will be equal to the current leaving, or the current leaving is equal to the current entering. So, current leaving, which is IE, is equal to the sum of the current entering, which is the IB and IC. Now, to solve for IE, isa-substitute lang natin since meron na tayong value ng IB at IC. Makukuha natin 24.04 microamperes plus 2.404 milliamperes. Now, the value of our IE is equal to 2.428 milliamperes. Okay, di ba? Ganun lang kasimple. Now, finally, we can now solve for the VCE. And to solve for VCE, okay, gagamitin natin yung niloop natin sa umpisa dito sa right side or the output side. And to solve for that, okay, nakuha naman na natin yung KVL niya kanina pa, which is VCC minus ICRC minus VCE is equal to 0. Now, para makuha natin yung VCE, ita-transpose lang natin siya sa kabila. So, makukuha natin VCE is equal to VCC minus ICRC. Now, substitute lang natin VCC, which is 12 volts, minus IC, which is 2.404 milliamperes, multiplied by RC, which is 2.2 kilo ohms. Okay, the value of VCE now is equal to 6.71 volts. Okay, di ba? Ganun lang kasimple. Our final answers now is IB, which is 24.04 microamperes, IC, which is 2.404 milliamperes, which is, by the way, less than the IC saturation current, kaya tama ang sagot na to. And the IE, or the emitter current, which is equal to 2.428 milliamperes, VCE, that is equal to 6.71 volts. Okay? Diba? Sobrang dali lang.